Okay, guys, we're gonna work on 5C, where you can simplify expressions using distributive property. So probably the first thing we had to talk about is what distributive property is. And so we've been working with hands-on equations, and when we do that, what we've talked about is that this expression represents 5 sets of x plus 8. So when we see this, what that means is we have an x and an 8, 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 an x and an 8. So we have 5 sets of that. So we're going to have 5 x's plus 1, 2, 3, 4, 5 8s, which means we're going to have 5x plus 40. Now, we've talked in class about this being, I use that rule of thumb of mama's got to kiss the babies. You got to make sure mama kisses all the babies and only her babies. So you'll see later on there's some that'll be outside of this. Mama doesn't kiss those babies. You don't distribute to everything. It's only the 5 is attached through multiplication, the x plus 8. Now, one of the things that we've talked about is we can evaluate expressions to see if they're equivalent, because what we're saying is these two expressions are equivalent. Now, one of the ways we could check equivalence is to substitute a value into x. So if I put, say I put x equals 1, and if I plug that first in the first equation, or the expression that we had, 5 times x plus 8, then what we would see is we have 5 times 1 plus 8, which would be 5 times 9, because 8 plus 1 is 9. We take care of what's in the parentheses first, and then we multiply that, and that gives us 45. If we looked at our expression that we came up with down here, and we have 5x plus 40, and we put a 1 in place of that, we'd say we have 5 times 1 plus the 40, and 5 times 1 is 5 plus the 40, which gives us 45. And we could see that when x equals 1, for each one of these expressions, they both come out to be x equals 45, which means these two expressions must be equivalent. Okay, so that's a way that if you're not sure on the test while you're doing your homework, if you're not sure if you have the right answer, you can check. Now, not very many students will, but if you wanted 100%, that's one thing that you could do is check the evaluation by substituting a value into the x from the original expression and the expression you simplified to, and see if they have the same values when x has a certain value. You could pick x equals 2, x equals 20, x equals 10, but if they come out the same, then those two expressions are equivalent. Okay, so now when we look at this is a little different because we have something out here. The thing you have to remember is this part here is the only thing the 5 is being multiplied times. So this is going to be 5 sets of 3x, and we talked about earlier that we would turn everything into addition. So we'd say plus negative 7. This is 5 sets of that, 3x plus negative 7, 3x plus negative 7, 3x plus negative 7. This is just to get across what this is communicating. and then adding 12. So then what we're going to do is we have 5 sets of 3x plus 5 sets of negative 7 plus the 12. Which means we have 15x plus negative 35 plus 12. Now, some of you might leave it here and think, okay, well, I'm done, but this is not simplified because you still need to put these together. So if I put those two together, then that's going to be 15x and negative 35 plus 12. If I'm at negative 35 and I go this way 12 to the right, then I'm going to be at negative 23. So this is going to be plus negative 23. And that can be simplified to be 15x minus 23. Either one of those two answers, this answer or this answer, would be correct. In 8th grade, they're going to expect that you're going to simplify it by putting these two together. Okay, so what we just did was I showed you this so you could understand where distributive property comes from. But if you had 5 times 3x minus 7 plus 12, you could do this quicker by just saying I'm going to have 5 times 3x plus 5 times negative 7 plus 12. And then simplified this to be, that's 15x plus negative 35 plus the 12. Then simplified these two, came out with 15x plus negative 23. So what I showed you on the left-hand side over here is to explain to you why you use distributive property and what this expression communicates. And then, but you don't have to always draw what I've drawn out here. You could just do what I've done here on the right-hand side and just distributed the 5, simplified, and combined like terms. Okay, the way this problem is different is that we have a negative here, and we've got to pay attention to that because what students will do is people will drop the negative. Remember, that's fulfilling Bruno's prophecy, is you would drop a negative. That's one of the prophecies. Students tend to do that, and I tend to do that sometimes. So again, what we're going to have is we're going to distribute the negative 4. And we've talked about if Mama's kissing the babies, she makes sure she kisses all the babies. And these are her babies. This one's not one of her babies. It's a kid outside of the house. So she's just going to kiss those 2. We're only going to distribute the 4 to the things that are in the parentheses. And we're going to distribute the negative 4. So I'll have negative 4 times 3x plus negative 4 times the 6 minus the 10. Now again, I'm going to make this plus negative 10 because I want to make this addition so that I can commute like terms and combine like terms. So when I look here, I have negative 4 times 3x, so that's going to be negative 12x, plus I have negative 4 times 6, which is negative 24, plus negative 10. My like terms are here. Negative 24 plus negative 10 is going to be, again, if you're not sure, draw a number line. Negative 24, and if I'm adding a negative, I go to the left. So that's going to be plus negative 10, and that means I'm going to be at negative 34. So this is going to be negative 34, and then I'm adding that to the negative 12x. This is different. These are x's, these are not. Don't put lions and puppies together. Know when to stop. This is when you stop. Some of you may look at that and say, oh, that's going to be negative 46x. That means you don't know when to stop. So know when to stop. This is where you stop. Again, I can double check. Let's say I did add those two together on accident, and I didn't know what I was doing. I gotta make that red so you know that's not what you're supposed to do. So negative 46x. So now what I'm gonna do is to check and see which one of these is equivalent. Okay, so we talked about the check equivalency. What I'm gonna do is plug a value in. Now on this one, if you plug a 1 in, but for some reason it works. But it doesn't work if you plug a 2 in. So we're going to plug a 2 in for x here. So you have to be careful. But I did not expect this, but it works if you plug a 1 in. So if you plug a 2 into this, because remember, if these are equivalent, no matter what number I put into x, it comes out to be the same. That's the difference between doing this and solving an equation. Because when we solve an equation, there's only one value that will work to make that equation come out balanced, for those to be equivalent. So when we're looking at this, we're going to plug in x equals 2. So I'm going to have negative 4 times 3x plus 6, and then minus 10. And I'm going to plug a 2 in, so I'm going to have negative 4 times 3 times 2 plus the 6 minus 10, which is going to give me negative 4 times 6 plus 6, which is going to be at minus the 10, which is negative 4 times 12 minus 10, which is negative 48 minus 10, which is negative 58. That's if we take our original expression and put in place 2, okay? So now we're going to plug 2 into negative 46x. So if I have negative 46 times x, and I plug a 2 into there, negative 46 times 2, this comes out to negative 92. This is not the same as negative 58. So these are not equivalent expressions. So now let's check with the negative 12x plus negative 34. So we'll move that up above. If I have negative 12x plus negative 34, and if I put a 2 into x, I have negative 12 times 2 plus the negative 34, and that gives me negative 24 plus negative 34, which is negative 58. Notice these two are equivalent. We took our original expression, plugged in a 2, and we got negative 58. We took the expression where we simplified this one here before we combined unlike terms, and we still got negative 58 when we put a 2 in there. That's how we know those two are equivalent expressions. You can check it anytime. So again, if you're struggling, you think you got it, but you're not sure, plug 2 in. Because we're finding out 0 definitely has problems, and 1 can have issues too, evidently. And so be careful, plug a 2 in, see if they come out equivalent. Okay, so now when we look at this one's a little different, isn't it? Now I really want you to understand, I'm looking at the test, and putting problems that you're going to need to know how to do. I'm putting these reviews, these problems up so that you can be successful on the test. If you can do these problems, you'll be successful on the test. You'll notice that I gave you review sheets that had these kind of problems on them. And so be careful, but watch what we're doing. Come and ask questions, but watch this video, take good notes, and you'll be fine. Okay, so on this, the first thing we're going to do is this is supposed to not have, this is not supposed to have this X in here. So just imagine that doesn't exist, okay? All right, it's the third time I put the PDF on, and for some reason it keeps putting that X in. Okay, now this is different, right? Because what this says, if we write everything as addition first, it helps us see things a little better. So what we would write is, we'd have this, and this would be 7 plus negative 5 times 3x plus 2. Okay, so what we need to remember is this is multiplication. We have to do the multiplication before we can do the addition, or before we can do subtraction. So we have to, you could do this two different ways, but you would have to remember that you're subtracting. So the first way would be to write this as addition so you see the negative 5 and distribute the negative. You have to make sure that the negative goes to both the 3x and the 2. So we would write this as 7 plus negative 5 times the 3x plus the negative 5 times the 2. Okay, so now we simplify this. We have 7 plus negative 15x plus negative 10. Remember, we have addition so that we can commute like terms, because the x's aren't the same as the 7 and the negative 10. So we're going to put these two together. So as we move things, we're going to say we have negative 15x plus 7 plus negative 10. And if we look at 7 plus negative 10, that means we started at 7, we moved to the left 10, means we got past 0, and we're at negative 3. And for some of you, this is still going to be a problem. Draw the number line. Be okay with that. If you need the number line, it's a tool. So this is negative 15x plus negative 3, which could also be written as negative 15x minus 3. And remember that this is the way they're going to expect you to do it. Negative 15x minus 3 is the simplest form of that expression. But this negative 15x plus negative 3 is acceptable in 7th grade, because it still communicates you know what your two different separate terms are, and you're not combining unlike terms. So the difficulty in this problem is a lot of students will take and they'll first simplify the subtraction. You have to remember about this multiplication here. You have to do multiplication before you can do subtraction. So you have to distribute that negative 5. Some students will just distribute the 5 but forget about the subtraction. But you have to remember you're subtracting 5 sets of 3x plus 2. Okay, so hopefully you've looked at this, you've written some notes. Okay, so here we go. This is a little harder, huh? This is pretty tough. You have to be really careful. So the first thing we're going to do is rewrite everything in addition, because then we can commute and then we see what we have to distribute. it separates things out so we can use commutative property. So we're going to have 4x plus negative 2 times 8 plus negative 2x plus negative 9. Okay, and I hope you're seeing that the color, the blue, is what we changed. We went from here, we just basically said if we're doing subtraction, we get the same result when we add the negative. Just as if we had 4 minus 3, we get, that'd be 1. We get the same result when we have 4 plus negative 3. That gives us 1. And here we can use commutative property, but here we can't because 3 minus 4 is negative 1, not 1. But negative 3 plus 4 is 1. So we're changing things to addition so that we can use commutative property. Okay, so we've changed all of these to addition. So now what we're going to do is simplify. So again, we have 4x, and then we were supposed to distribute the negative 2 because it's being multiplied by both of these. So we're going to have negative 2 times the 8 plus negative 2 times the negative 2x plus the negative 9. Now we need to simplify these two after we've used distributive property. So we're going to have 4x plus negative 16 plus negative times a negative is a positive. 2 times 2 is 4 plus positive 4x plus negative 9. Now we're going to combine like terms because we've simplified we've done the distributive property. And we remember we looked at this and we are not distributing. The distributive property applies here. It does not apply to the 9. Only to the things that are in the parentheses. Okay, so now what we have is 4x. We can combine like terms, which means we can put our x's together and we can put our numbers together. So we're going to have 4x plus 4x plus negative 16 plus negative 9. 4x plus 4x is 8x plus negative 16 plus negative 9. If I'm at negative 16 and I add negative 9, I'm going to go to the left. Zeros over here. So I'm going to be at negative 25. So this is going to be plus negative 25. And I'm done because now I have unlike terms. I have lions and puppies. Don't put them together. So that means our final answer will be 8x plus or 8x minus 25. That's the perfect solution. Okay, so this one might take a little bit of work to understand. If you didn't get these steps, then well, review it again. Remember, this is all about distributive property, applying distributive property correctly. The only thing that negative 2 is attached to is the 8 and the negative 2x by multiplication. So you don't apply it to the negative 9, you don't apply it to the 4x. Once you've used distributive property, in this line we applied the distributive property. Here is the distributive property. After that, we're just simplifying and combining like terms. Okay, this one's scary, huh? Well, because it has a fraction. But if we looked at that and instead of looking at the fraction as a scary monster, we just looked at it and said, well, what would we do if it wasn't a fraction? Okay, so now remember, I said this once before, and some people got it, but then some people thought, oh, we can change it. We're not changing the number. I'm just saying, imagine what would happen if this was not a fraction. If you had 2 times 7y minus 1/5, and then you would look at that and say, well, I'm just going to multiply the 2. And then you'd say, well, I have 2 times 7y minus 2 times 1/5. And you might get a little nervous with that minus 1/5, and then you'd go ahead and add the plus 4/15 over here to the edge. But you would have distributed the 2, right? So this isn't a 2, but we're going to do the same thing with it. We're going to distribute the 1/3. And we're only going to distribute to what it's attached to. That's the parentheses. This is not within the parentheses. Distributive property is we have the 1/3 times what's in the parentheses. So now what we're going to do is we're going to distribute this, so we're going to have 1/3 times 7y minus 1/3 times 1/5 and then we're going to have plus 4/15. Okay, so here we go. Now we're going to simplify this. And again, because that's 1/3, we're going to rewrite this as 1/3 times 7 over 1 times y. Minus 1 times 1 is 1. And 3 times 5 is 15. And then we're going to have plus 4/15. Now remember, I'm purposely doing this one, the 4/15 in black, so you can see it's not a part of the distribution. We just have to pay attention to it at the end to combine like terms. Now, so we've taken care of this distribution. This right here, the 1/3 times 7y, would wind up being 7/3 y. And then we're going to write this as addition, the next part. So we'll say plus negative 1/15 plus 4/15. So the negative 7/3 y, that stays like that. And these two are like terms, and they also happen to be already in 15ths. So we don't have to change to a common denominator. Since they are a common denominator, then we can just say we have 7/3 y plus, we're going to have over 15, negative 1 plus 4, which means we have 7/3 y plus 3/15, plus 3/15, and 3/15 reduces to 1/5 because 3/15 is the same as 1 times 3 over 5 times 3. And the 3's reduce to be a 1 because 3 divided by 3 is 1. So this equals 1/5. So that means our final solution is that we have 7y, 7/3 y, plus 1/5. And, if it you need to understand that, but that also is 2 1/3 y plus 1/5. And we have to stop there. We're done. So the scariest part about this was that you had a fraction involved. You have a lot of fractions involved. So you have to be careful about your fraction math. You have to be careful that you just distribute the 1/3 into the parentheses and that it doesn't get distributed to the 4/15. So the scariest monster in this problem is the fractions. That's where more of you are probably scared to look at it. But if you can get through the fraction math, but that's why this is what gives you a 4. If you can do this, you get a 4 out of 4. If you can't do the fraction math, then you'll get a 3 out of 4. Part of the standard is that you can do it with rational numbers. Okay, well, that's 30 minutes. So if you've got any questions, come see me after school. Come see me before school. Come see me at cave time. Okay, good luck.